Okay, let's try this again. Today we're looking at vertex form of a quadratic function. And the vertex form of a quadratic function is y equals a bracket x minus p quantity squared plus q. So, Sky, there are three variables here in this function, a, p, and q. A, P, and Q are what not only tell us things, but they will help determine what the graph looks like. So what I'm going to do is the investigation part of this says your teacher will guide you to see how A, P, and Q affect the quadratic function when they're changed. So you don't have to have Desmos because I've got Desmos. I've got Desmos right here. And what I'm going to do is I'm going to type in that equation. And in this screenshot, we see that we can change the values of A, P, and Q. And what we have to do is we have to see what changing A, P, and Q does to the red parabola that we see pictured right here. So here's the thing. If I change A, we've seen A before. If I change A, if I make A bigger, what happens to the graph? What happens to the graph as I make A bigger up here? Narrow or skinnier, okay? So if I increase A, it gets skinnier. We're going to write this down all together in a few minutes. I just want you to watch what's happening up here so you can understand it. So if I decrease A, what happens to the graph? If I make A go smaller, what happens to the graph? It gets wider. And when A is negative, what can we say about the graph? It points down, and we can still say that if we ignore the sign, as the number gets bigger, the graph gets skinnier. As the number gets smaller, the graph gets wider. Okay? So what we're saying about A is the exact same thing we said about A before. But we haven't dealt with P and Q before, so let's deal with P and Q. As I make P bigger, let's look at what happens to the graph. As I make P bigger, what happens to the graph? It moves to the right. If I make P smaller, it moves to the left. If I make, let's see what happens if I increase Q. If I increase Q, what happens to the graph? It moves up. If I decrease Q, the graph moves down. Okay? So on the next page, we can say the following things about the parameters. So this is what we'll say. This is what we'll say. As if A is positive, the graph points up. If A is negative, the graph points down. Ignoring sign, as, see if I could move this. Well, I can't move that, but whatever. So actually I could. That's what I'm going to do. I'm just going to make some more space here. I'm going to bring up the keyboard here and just go. There we go. Now I can hide the keyboard, I think, somehow. There we go. Perfect. Ignoring sign, as A gets bigger, the graph becomes skinnier. As A gets smaller, the graph gets wider. We can also say a few more things, obviously, about P and Q, and something else that we haven't quite said yet, but we'll get there. As P gets larger, the graph moves to the right. As P gets smaller, the graph moves to the left. Q is similar. As Q gets larger, the graph moves up. As Q gets smaller, the graph moves down. But we can say something else. If we look back at the graph, here, P is a -4, Q is a -7. What's the vertex of my graph? Vertex of my graph is -4, -7. It's no coincidence. When we're talking about the vertex, this is why this is called the vertex form of the graph. the vertex of a parabola has coordinates P and Q. So we can say that PQ is the vertex of the graph. Okay? PQ represents the vertex of the graph. Now, I think, yeah, good. All right, let's do some examples. Sketch the graph. What's that? Okay. All right. Sketch the graph of the following quadratic functions. Start off with 2 times x minus 1 squared minus 8. How do we graph that? Well, according to what we just figured out, we know that this is the vertex, and not exactly the vertex, but it's the vertex. In vertex form, we have to be careful. In vertex form is x minus p, So whatever number's in brackets, we have to take the opposite sign. So what's in brackets here is -1, so that means that +1, and this number, just as it is, -8, represents the vertex of that graph. The vertex of that graph is 1 and -8. Now, in which way is that graph pointing? Up or down? Up. A is positive, sure. So I'm confident if I'm making the graph that I can use the traditional -10 to 10, -10 to 10 scale. 1 -8 is going to be right here. Now, what we have to do is we have to construct the rest of the graph. And I'm going to show you how we do that. Because here's the thing. There's one other thing we have to keep in mind. And we have to keep in mind the 2, which is the A value. The A value, as we saw, will either narrow the graph, make it skinnier, or it'll widen the graph and make it look fatter. But the question becomes, how do we do that exactly? Well, here's what I could tell you. Okay? We're going off the grid here. Going to go off to a separate piece of paper, if we will. I'm going to actually come on. I'm going to actually, no, I want this. Yeah, come on. Yeah, okay, good. What the heck? I'll go with this guy here. All right. Oh yeah. Okay. I'm gonna make this nice and big. There we go. Okay. Here's what I could tell you about standard parabola. How we graph it. Very important information. Gonna want to make sure you're watching carefully. Vertex I'm just going to do x squared here because it's the simplest one. Vertex is going to be at 0, 0. Okay? Vertex is going to be at 0, 0. I'm going to say that this is 1. Actually, no, I'm not. I'm not. What I'm going to do is I'm going to stick to the negative 10 to 10, negative 10 to 10 idea, okay? Because I want to show you something very important here. I want to show you something very important. If we want to graph these points, we can make a table of values. I showed you how to do that on the graphing calculator. What's 1 squared? 1. So I've got a point at 1, 1. I'm not in love with my smartboard right now because it's a little bit off. And if I'm graphing, I really shouldn't be off at all. Moving on, what's 2 squared? 4. So I'm going to put a point at 2 and 4. And going on to the next one, what's 3 squared? 9. So I can do this. And I could do it on the left half as well. Negative 1 squared is 1. Negative 2 squared is 4. Negative 3 squared is 9. So I get this. But what's really important to see here is something else. I mean, it's important to see this, but it's important to see something else because it's going to help you graph quadratics from now on. Here's the thing. From the vertex, I go over 1, up 1. That's over 1, up 1. Then I go over 1, up what? Yeah, up 3. Then I go over 1, up 5. What's important that we look at here is this. Up 1, up 3, up 5. Does anybody want to hazard a guess what we're going up by next? 7, and then 9, and then 11. Right, exactly. So what we're going up by are odd numbers, okay? And the same is true over here, that we go over 1, up 1, over 1, up 3, and over 1, up 5. That's when A is 1. If we change the value of A, what we go up by changes as well. So if I went up, if A changed to 4, if A was any number, we're going to pick 4 just for whatever, then I have to multiply these jumps, if you will, by 5. So you'd go over 1, up 5, over 1, up 15. Actually, sorry, my bad. I can't multiply today. I'm multiplying by 4, not 5. Over 1, up 4, over 1, up 12, over 1, up 20. Make sense? Okay, so back to this question that we're doing, it's 2. So instead of going over 1, up 1, over 1, up 3, over 1, up 5, that is going up by 1, 3, 5, we are going to go up by 2, 6, and 10, okay? So let's try that. Let's try that. So I'm going to go over 1, up 2. That's going to land me right here. And I can do it on both sides. Over 1, up 2. Then after I do that, I'm going to go from those red points. I'm going to go over 1, up 6. So that's over 1, up 6, and I land right there. Exactly on the x-axis. So that actually tells me my x-intercepts are -1 and 3. And then I'd go over 1, up 10, and end up here. And obviously, based on the scale you choose, you'll only be able to put a few points on the graph. And that's okay. But once you have those few points, what you can do is you can connect them and make a parabola. So that right there is 2 times x minus 1 squared minus 8. That's exactly how we graph that. Okay? So that up 1, up 1, up over 1, up 3, over 1, up 5, where the 1, the 3, and the 5 are multiplied by whatever the A value is. So we'll use the same strategy in this next graph. What's the vertex going to be for question B? What's the vertex going to be? What? Okay, be careful. Maybe we take the number that's in here, we don't square it, and we take the opposite sign. So it's -3 and 2. So we take the 3, but we take the opposite sign. So that gives us a vertex of -3 and 2. And will this graph be pointing up or down? Down. It will be pointing down. So I'm going to use the same scale, -10 to 10 and -10 to 10. And I'm going to start with my vertex at -3 and 2. And then I'm going to start finding more points. Not considering what the sign is, just the number, A is 0.5. If A is 0.5, then that means that we have to multiply those jumps by 0.5. So instead of going over 1, down 1, because the graph's pointing down, we're going to go over 1, down what? Half. Over 1, down a half. So over 1, down a half will land us right there and right there. Best as I can draw it. From those points, instead of going over 1, down 3, we're going to be going over 1, down 1.5. And if we go over 1, down 1.5, again, we're actually going to end up landing right on the x-axis on both sides. And then from there, we'll go over 1, down what? 2.5, yes. Over 1, down 2.5. And because we still have some more room, we could keep going. So to keep going, we would just kind of have to extend this a little bit. 1, 3, 5, and then what would be the next one? 7. So instead of going over 1, down 7, we'll be going over 1, down 3.5. And the next one would be 4.5, and we just run out of room to do that. So we'll actually stop with these points, and we'll draw a curve that goes through these points. You want to make sure your scale allows you to have at least probably a few points going in each direction from the vertex, but as long as you have a few points going in each direction from the vertex, it'll allow you to draw the graph. And this is the cool thing. By looking at the equation of a parabola in vertex form, which is what we're talking about today, we are able to graph the parabola perfectly. A lot of what we do in this class is stick an equation into a calculator or Desmos and let it graph it for us. But what's really cool about this, I think, is if we have an equation in this form, we can graph it all by ourselves. We don't need a calculator to help us. We can do it on our own, okay? So here we have an equation, a graph, and we need to generate the equation, okay? We need to generate the equation. So we know that the vertex form is y equals a bracket x minus p squared plus q. What is the vertex of this graph? 0, 4. So substitute those values in for p and q. So y equals a bracket. Now x minus 0 is just x. So I can just actually write x squared and then plus 4. And then what we need to do is we need to figure out that a value. Now we can figure out that a value a couple ways, just like we did the other day. We can plug in a number for x and y on the graph and solve for a. But we can also use that over 1, up 1, over 1, up 3 stuff. Because here's what I see. I see that I go over 1, up something, not sure what, over 1, up another something. But I started at 4. How high am I after 2 ups? Like I'm right here now. How high did I go in those 2 jumps? What's that? 6 total. So this is 6 total, right? That's 6 total. Now, if we think of the way we do it for the standard x squared, we go over 1, up 1, over 1, up 3. So in 2 jumps, we go a total of what? Yes, and if it was just x squared, we'd only go a total of what? 4. So, what do we multiply? What do we multiply 4 by to give us a jump of 6? 1.5, right? 1.5. Because this is going to be 1.5, and this is going to be 2.5. No, 4.5. This is 1.5, this is 4.5. So this is 1.5. So it's y equals 1.5 x squared plus 4. So if you use the jumping idea and you see that after 2 jumps you should be up 4, but really you're up 6, then just ask, well, you could just divide 6 by 4, you could just divide 6 by 4 and you get 1.5. Okay, so a is 1.5. So the equation of the graph below is y equals 1.5 x squared plus 4. One more question. Cashton kicks a football straight in the air. It reaches a maximum height of 18 meters after 1.6 seconds. It returns to the ground after a total of 3.2 seconds. Part A, create a quadratic function to model the height of the ball. Part B, after 2.5 seconds, what's the height of the ball? So here's the deal. Here's the deal. Not just in math, but in general, we can say that a picture is worth 1,000 words. And if we draw a picture here, it's going to make our lives easier. So here's the deal. A ball is kicked, it reaches some maximum height, it comes back down to the ground. So this would be the time, and this would be the height. We are up against the clock here with 2 minutes to go, so I'm going to ask for your patience as we finish this last example, okay? So it reaches a maximum height of 18 meters after 1.6 seconds. That tells us that the vertex is 1.6 and 18. It comes back down to the ground after 3.2 seconds. So we can use this to help us come up with an equation, okay? Because what we know is that the vertex form of a quadratic is y equals a bracket x minus p squared plus q. And up in that graph above, we know the vertex. So we know that y equals x minus 1.6 squared plus 18. We know what p and q are. What we need to do is find what a is. And we're going to use any other point that we have on the graph. And we have two other points on the graph that we could use. We could use 0, 0, where it starts when the ball's kicked, or we could use 3.2 and 0. In either case, we substitute x and y into that expression and solve for a. I'm going to use 0, 0 because it's nice. 0 equals a bracket 0 minus 1.6 squared plus 18. Zero minus 1.6 is negative 1.6. Then I'm squaring it. When I square 1.6, I get 2.56, and that's times a. If I want to solve for a, I need to bring the 18 over to the left side. And when I bring anything over to the other side, the sign changes. If I want to know what a is, I need to divide negative 18 by 2.56. So, if we divide 18 by 2.56, we get, if I round to 2 decimal places, negative 7.03. So what that tells us is is the equation is y equals negative 7.03 x minus 1.6 squared plus 18. That's the equation that models the kick of the ball over time. But that's only part A. We still have to answer part B. And part B asks what the height of the ball is after, I believe it's 2.5 seconds. Part B is very easy. We could do it on the graphing calculator. We could do it on a standard scientific calculator. We don't need anything fancy to do part B. All we need to do is plug in 2.5 for which letter? X. X represents time. So part B, y equals negative 7.03 times 2.5 minus 1.6 all squared plus 18. We know it reaches its maximum height after 1.6 seconds. So we know it's going to be on the way down. If we do all the math, we are going to get a height of 12.31 meters. Is it meters? Yes, it's meters. That's the height after 2.5 seconds. Okay? Your homework is on pages 417 to 421, numbers 1 to 19. There is a quiz on this tomorrow, so please do your homework.